areas. Everybody remembers the ones? Okay, because if you try to find the determinant with just a 3 by 2, it won't work. It has to be square. For some reason, ones work out there. Somebody figured this out and put ones in there, and we're able to find the area. So everybody's okay with these? And if your determinant comes out negative, such as this one, then you're going to multiply it by the negative 1/2, because area always needs to be positive. And a determinant can be negative. Okay. Again, I do this, but on the test, there's always at least 1 or 2 kids that forget the 1. Okay. You could leave it as a decimal. You could leave it as an improper fraction. You could leave it as a reduced fraction. Technically, it probably should be, instead of this, it probably should be an improper one. Whichever way you left it. Good? So those were the easy ones, right? Okay. Kramer's rule. Kramer has a nice little rule going on here. Would it be my choice to solve? No, but using a determinant is very powerful. So using a determinant, it's a nice little rule. Separate your coefficient versus your constant. Gabby, you missed this. So we took this, and so just to review for everybody, separate your constant versus your coefficient one. Find the determinant of this major one. This is your major determinant. So keep track of this guy. This one? Put it in your calc. Or do it this way. A 2 by 2 you can do. -9 times -7 is 63. Minus 33 is 30. A 2 by 2 you're going to have to do by hand, right?
Why is it minus 33?
Because that's the rule. You take the product of this one minus the product of that one.
Oh, that's why I got it on that.
You added them. But put it in your calc and check it. So that's what I was saying. So if you forget how to do it on the test, and you added them, if you check this in your calculator, you'd see that answer was wrong. But by looking at it, if you see 63 and 33 and your answer came out to be 30, wouldn't you see that you should have subtracted? Right? Bram?
Why do you feel like the -1 and 9 for when you solve for x?
So when you're solving for x, this is your x row, this is your y row. This is where x is, this is where y is. You take this constant row and you put it in place of x. And then you find that determinant. Oh no, it's got to be in the right place. And again, you can do it. 9 minus 9 to 9 will give you -90. Now, here's the key. You take whatever you found for x, that determinant, and you divide it by the major one. So that gives us a -3. That's part of our answers. That's your solution. And then you go back, you got to remember, go back to the original one. Go back to the original one, and then just replace the y with this constant row. Make sure you bring it back to the original. Otherwise, you're going to have 2 the same rows in there. Find that determinant, and then divide that out and find your y. Once you find your y, you can give it to me like this, or probably this. It makes a better solution set. Remember, you're looking for the solution set. If it has 3, you need an x, y, and z. You just do it a 3rd time. If it has 4, you do it a 4th time. It's a powerful tool to use with a determinant. Good? Ask me questions. Don't be afraid to ask. Somebody's probably thinking the same thing. Okay, this one, we could see that this is not going to be possible because if you even go attempt to put x in, you're going to divide by a 0. Can you divide by a 0? No. So this one was not possible. Remember, sometimes a square also does not have a determinant. Oh, it always has a determinant. Sorry, it doesn't have an inverse. But in this case, if you did it out, as soon as you went to go divide the first one, you would see that you couldn't divide by 0. And that happens. probably was a longer one. Just keep your pattern going. If it helps, like circle the row. I realize I have an advantage because I have different colors. But if I was doing this, I would circle this, make sure I replaced each one with the constant row. Okay, make sure you replace each one. Find your major determinant, find each one, and divide them out. And give me your solution. Make sure I get a solution here. This one is awfully down here. Make sure I get a solution. Questions? Did you find this easy? Good. Very good. If you didn't, tell me. It's probably just a little something you're missing. Okay, again, you can have fractions in your answers. Our solutions do have fractions. So find the determinant of the big one. You probably should keep this a capital D. And then the determinant of all the little guys. And then divide them out. And get your solution. Okay. Other questions? Uh-huh. So for the first few, are you okay with this?
Yeah.
Okay?
Oh, wait.
A times B, when you multiply, you're going to have to multiply this out. This is the one thing I asked you to multiply out. That's why I said do not use a calculator. Or she was supposed to tell you, do not use a calculator. Okay. Make sure you multiply these out by hand. And make sure it works first in the middle. I don't know why this is so like tiny, my writing. Okay, so make sure you do this first, multiply it out, check to see that they can be. This guy can't be. So if I was looking to see if these were inverses of each other, not knowing what they look like, and if this doesn't work, then they can't be automatically inverses. I have to be able to multiply them. I have to be able to get the same thing. Make sure you can multiply one out. Do your row times your column. Row, this column. This row, this column. Inverse, just plug it in and say inverse. Use your inverse C. Flip it to a fraction. No decimals. You can't round on these because you will never get back to your original ones. Make sure you're able to do this one. Make sure you're able to show me. And if you don't show me how you do this, you're not going to get credit. I want to see this, or it's written down somewhere. I need to see this. If you only give me an answer, it's not going to give you credit. The 2 by 2 is the only one we ask you to find the determinant for.
Wait, you said if we only show...
If you just give me an answer, there's no credit. You've got to show me this. I need to see your pattern. But remember, you have your calculator. So if you forget how to do it, you put it in your calculator, you get your two products. So all you can really do is get your two products. So do you add, do you multiply, do you divide, do you subtract? So once you see the answer, in looking at those two, you'll realize you're subtracting. It's kind of just a little cheating way. Okay. All right. Can you guys see it? I make it too big. All right. Hopefully you can read this. All right. Is everybody okay with this? The one you just did, and you did this now, everybody was so good with it? Okay, when you did the inverse, did it come out the same answer? Okay, inverse again. Make sure sure you can do this tomorrow. Inverse. Just make this one matrix, so I can call it A. Make this one matrix, I'll call it B. And A to the -1 times B. Now on the test, I asked you to show me all your matrices. So before you actually do this, show me what your inverse matrix looks like. Just do A to the -1, flip it to a fraction, and just give me your matrix. I want to see the inverse matrix. Remember, I'm only asking you a couple of these, so you're going to have to give me your steps. What I would do also, since you're taking a test, once you put your matrix in, just go to that matrix letter, hit enter, display it on your calculator. Make sure those are the numbers you want. Because the minute they're going wrong, and you put another matrix in, you don't see it, I don't see it.
So for inverse, couldn't you like also do like the A times B and B times A?
No, that proves that two matrices are inverses of each other. But if you're going to solve the solutions of equations using inverse, you have to do this. To prove that they're two inverses of each other, you would do A times B, B times A, and get the identity. Did I have one of those on here? No? Okay, can everybody do RREF? The RREF, enter the whole thing. Enter the whole thing into one matrix. So it will be a 3x4 matrix. And then just go to the math part. Just go up to RREF and just do this, and you get your answer. But remember, it's going to come out like this. And what was the solution for x? 3. It's going to look like this. So this part right here is where your solution is. X on, Y on, Z on. Remember, it's like a binary thing, on and off. The nice part about like Kramer's rule is you just get your solution. Same thing with the inverse. You just get a solution. You don't get this. You don't get the identity part in there. You're going to have to do it all 3 ways. Okay, 18 points consisting of, make sure you give me a let statement. So I'm going to have my let statements here. You're going to recognize this by 3 variables, 2 equations. Okay, the coins are always popular. Coins, getting tickets for things, those are always the popular ones.
For the R, yeah, we're gonna plug it in like 0, 0, 1.
0, 0, 1. Check the matrix first.
Everything else is like the inverse.
Okay, let's print out your matrix statement. I don't have constants in here. You don't have any constants filled in here. Okay. God bless you. Everybody good with this?
Yeah.
Yes? Critical part right here. Make sure you remember to do this. From here, if it helps you, put it on the number line. Remember, I want integers, positive integers, so I'm looking for 9 and 10. These are the only possible ones I could have. That might not work either, but those are the only possible ones I could look at. Okay. Okay, Mr. Nee again. Mr. Nee was buying pens and pencils this time. He had to buy exactly 21 items, so therefore they added up to 21. And he had to spend $36. Okay, so again, we have a bunch of different solutions for him. On your number line, you can't go to the negatives, so open it at 0 to open it at 12. So technically, from 1 to 11, you're looking at. If you want to write the whole thing out, 1 to 11, and just cross out the ones that don't work, it's up to you. But your final answer should look like this. I don't want your table as your final answer. This is your solution set.
Why do you go like 15, 4, 2?
Because it has to go in order, X, Y, Z.
Oh, yeah.
So it has to be X, Y, Z. If I don't get it like this, you're going to lose points on that. Okay? X, Y, Z. Finding a determinant again. Make sure you show me how to do that. How you did it. Did you check it in your calculator? I don't see that you checked, so I don't see why not.
You have to subtract the 2.
Yep, then you got to remember to go up, multiply up. Don't multiply down, you get something different. Go up and subtract. And then your last part, finding a determinant, using a determinant, find the area. Remember to fill those with 1s. Good. This is basically the same thing that's on your test. Nothing different. Yes.
But doesn't it have like a matrix or something that has decimals in it like for your answer and you have to switch it to fractions in the calculator? What do you call it?
Math, enter, enter. As soon as your matrix appears, just you don't do any other things after that. Just say math, enter, enter. It takes your fraction, puts it through fractions.